Okay, so good evening, everyone. So my name is Esteban García Cuesta, and I have done a work about big data architecture for prediction and decision taking in clinical environments, jointly with some of our colleagues in European University in Madrid. And me and Rafael Muñoz, we are going to present this work that we have done in this innovation area, or this area is an innovation project, let's say. So the idea of this project, or the motivation of these projects, is to see how we can deal with data and how we can use the data that is provided by clinical systems or by healthcare systems in order to improve the quality of life that we have. So the main motivation is due to, nowadays, due to smoking, for instance, there are 16 million of Americans which are living with a disease which is caused by smoking. Also, there are 6 million of deaths per year, and the trend seems to be like it's going to increase. So probably by 2030, it's going to be like 8 million deaths due to smoking. And also, it has a cost in the medical system. So currently, is in US, this cost has to, or is supposed to be related with 170 billions in direct medical care. So these are some actual data, which you can find there, the references. So furthermore, we have also that the cost in productivity is estimated to be as 156 billions. If we talk about another known problem, which is obesity, which also causes disease, and at the end of the day, mortality also can be due to obesity in the long term, we are talking that in general, it has been shown that it lowers the quality of life of people. It also causes depression. It also can cause type 2 diabetes. And also, at the end of the day, as I said, it could be, or it could end in mortality. This has also a cost in the healthcare system, which is 140, or is estimated to be as 147 billion cost in the direct medical care, and also has a cost in productivity, which is estimated to be between $3.4 and $6 million per year. So this is the motivation. So this is motivation for trying to see how we can help to have a new healthcare system, how we can use big data in the healthcare systems in order to reduce the cost of these systems and also improve quality of the system and our lives. So the idea is that we want to have 24 hours per day, every day of the year, of medical assistance, and we want to change from treatment to preventive. So the key here is we want a preventive healthcare system. We don't want something that treats the diseases, but something that that prevents the disease. In that way, our quality of life is better, and also the healthcare cost system will be lower. Also, these kind of systems can help to take urgent decisions, for instance, in intensive care unit, as we will see later in the sample that we have done. So we can show this idea of preventing in 3 different phases. The first one will be the long term, the mid-term, and the short term. This is nothing new. This is something that has been applied in the medical systems, or this idea of long term, mid-term, and short term is in the healthcare systems since 1960s. The advantage of having big data, a lot of data, and new technology is that now we can atomize all of this. So for instance, in the long term, we are talking about we want to prevent. This is the first step, the most important. If we want to prevent in order to reduce the cost and improve quality, this is the most important term. Here we are talking about controlling what we eat, controlling what we drink, controlling our style of life, doing sports, so on and so forth. We also can use, here, we can use some kind of historical data in order to see how to prevent in a few months or in a year, okay? So here we are talking about responsive type or we are saying that the responsive type is low. We're talking about months, okay? So the machine learning algorithms that we want to use, or the expert systems, have this time in order to think, let's say, or to take decisions. In the midterm, we are talking that we have a response time of days. So in this case, what we are doing or we want to do is to early detect a disease. It's not to prevent, but to detect it early. In that way, we can have some chances to go back as is shown in the picture, we have the chance to go back to the previous state of prevention, okay? So here we are talking about wearables. Okay, the wearables nowadays is in our day-by-day lives, so we can use these wearables and we can analyze the data we are generating and we can wear it every day in order to control, for instance, our heart rate. Okay, so in that way we are including this information in the system, and if we are doing well, we can go back to the prevention mode. In the short term, the response time is high. We only have a few minutes to take a decision. For instance, is whenever when we are in the care unit, in the intensive care unit. This is what happened, okay? We have a very short time for reacting, and we are treating the disease, okay? We are not preventing. This is what we usually do in nowadays. So in this case, we are just measuring some or monitoring some parameters, and that you just have an alarm, and you say yes, no, yes, no. And here the idea is to know if we can prevent, or we can know what is the probability of a person to save it in the short term, okay? So also, if we look at this from the intensive, or for the capacities that we need from the CPU from the processing point of view, we are talking that the long term is higher intensive because we can have more complex models and we have more time to develop these models and also to improve it. In the midterm, we have an average intensive processing task, which means that we can have, or we can treat lower amount of data, and also we need more simple programs or algorithms. And in the short term, what we are doing is to have some systems that say, if happens this, then do that, okay? And then we can have this model for going from the short term to the mid-term to the long term. So some possible uses in this system. So as you can see, this system allows to include new technology in many, many different ways. For instance, another project that we have, which is called iModelo, we analyze text for predicting opinions, for instance. In this case, if we are in the preventive mode, and we are saying a person that has to eat healthy, if we know how this person is going to feel whenever we ask him to eat this or that, then if we know the opinion that he has, we can say, okay, I'm going to recommend you this because I know that you are going to like it, instead of this, that you're not going to like it. So we are helping the person to do things which prevents diseases. We are not going to talk about this, but we are going to talk about how we can use in a short term an algorithm that is going to allow us to predict the mortality of patients. And for that, we have done a machine learning and big data approximation.
Well, good afternoon. I'm going to simplify the introduction by my colleague Esteban. We belong to a group of intelligence systems of a European university, and we have spent years working on management and information integration in e-health projects. The last project in which are immersed is the resolution of a challenge posted by Fissionet, a web resource open to the investigation of complex physiological science. As use case for data processing and analytics, we use real data set obtained from Fissionet Computing in Cardiology Challenge 2012. The title was Predicting Mortality of ICU Patients. The origin of data were the hospital medical information system for intensive care unit patients with ICU states at least 48 hours. Set was composed of 4,000 records corresponding to 4,000 patients, and each record was composed of 37 variables, time series variables such as heart rate, blood pressure, or temperature, which could be observed once, more than once, or not at all in some cases, and could be recorded at regular intervals, hourly, daily, or at irregular intervals. We conducted a study where, working with the same set of data, we processed it with different algorithms on various architectures. What we can deduce is that the algorithm is not very scalable. For an increase of 10 times the size of the data set, represents a 16-fold increase in rapid miner and more than 4 times in Java. In fact, up to 400,000 patients was directly impossible to run on Java virtual machine. Using Hadoop clearly shows how it's possible to reduce to less than half the run times on the same dataset and the same algorithms using big data technologies. Additionally, Spark, with this mode of operation, provides while enhancing traditional big data solutions. We designed and implemented a big data and Internet of Things based architecture for a chronic patients monitoring system. The system provides interface for through big data, Internet of Things, and cloud computing approach. Our system permits to process high volumes of data coming from non-invasive wireless biosensors and appropriate visualization of interface for each type of user. We use this architecture to process the challenge, and we select the logistic regression to process the data. The logistic regression was performed using the function GLM included in stats package of R. Our fraction of correct prediction was higher than the value obtained by the winner of challenge in 2012. This result suggests as the fraction of correct prediction of in-hospital deaths given by our model is relatively good. However, the fraction of in-hospital deaths given by our model was small. A possible cause is that the many variables, 22, were not taken account by the model. After seeing that there was a good result, we decided to continue evolving the project and use, in principle, all variables and all measurements that were made. The methodology used was the following. Preprocessing is difficult because we are going to distinguish, for example, temperature taking -7 as a variable, and temperature taking in -30 is another variable. This gives rise to more than 100,000 variables. To make this new logistic regression, architecture design in the previous project was scarce, and we needed a parallel processing. For this reason, we decided to integrate architecture processing in parallel with Spark and make use of the algorithms encoded in the machine learning library. In this work, we use the same methods to predict the survival or in-hospital deaths using a machine learning leap from Spark. The logistic regression was performed using the machine learning leap from Spark. Data preprocessing involves data cleaning for removing noise and data interpolation to mitigate the effects of the missing values. Data cleaning is a common step in machine learning application, and it becomes critical in medical environments because the data is collected for enhancing patient care. In the case of signal analysis, it's absolutely necessary to recognize true measurement from noise observation and data corruption. In this case, the logistic regression, we use a function provided by machine learning leap from Spark, named logistic regression with LBFGAs that train a classification model for multinomial binary logistic regression using low memory Breuer-Fletcher-Goldfarb-Shannon algorithm for parameter estimation. When there are a big number, that in this case of attributes, dimensionality reduction is a required step. It improves efficiency and reduces overfitting. There are usually two ways to do this task, feature selection and feature extraction. Up to this moment, we have made a vast process of historical data. This type of processing handles large volumes of information, but have a high latency, which creates a way to see the result. However, in some cases, we need in some data, we need the data be processed, just collected. And as in the case which concerns us, where upon enter a patient in the IQ, we should be analyzing the data so that doctors will act accordingly. This type of processing, this type of streaming processing has some difficulties because there are times when the data arise in real time, and that means a high speed. Spark provides us with a framework, Spark String, that consisting of a library that runs on top of Spark and provide a high level of abstraction and a grid, along with a grid performance. Operation consists of collecting data in a string from one or more sources and process and convert that flow in RDDs, which can now be processed by Spark.
So we can conclude that, well, we have used, or we have shown a way that we can use like a big data architecture, and we can include all the medical healthcare systems in there in order to, based on the predictions. So the idea is that we have the prediction in the long term, we have the prediction in the midterm, we have the prediction of, let's say, dying in the short term. At the end of the day, we are just predicting the mortality of a person. So in that way, we are able to predict constantly from the long term in the same way to the short term. Then we can always take actions in order to go back and trying to avoid mortality, but at the end of the day, reduce the cost in the mid and long term of the system, and also improves our quality of life, because it's going to help us to, let's say, die better. So in the long term, we think that this approach could assist by knowledge-based systems and intensive machine learning algorithms to do this. In the midterm, by using weak learners, let's say weak not in the way that is used in the ensembling area, but by weak, like less intensive learners focus on monitorization, for instance, with wearables. And in the short term, by controlling critical parameters of many. When we say many, it's the same platform for controlling critical parameters of thousands of people or hundreds of thousands of people on real time. So this idea will link, so the person is the flow in all these proposals. So thank you very much, and if you have any questions, it will be a pleasure for Rafael and myself to answer them. Please, one. Well, it's an open issue. I mean, it's very open. I think that it was very open, the presentation. So I'm sure you have any questions, because the schema that they show we show is very open. So for sure you have some questions regarding that, or any future ideas to share with us. Yes. Okay. Thank you very much.
Each one for the short term, long term, and mid term. So could you explain? I understood you got GLM with logistic regression. for one of them. Then you mentioned weak learners, so I think you are using random forest or something like that?
Yeah, well, it wasn't weak learners in that way. So we did, in a sample that we did, so the idea is we are working in one overall system which uses the data of a person, all the data that the healthcare system has from a person, okay? That's the assumption. So we are proposing that once we have that information, we can implement 3 different types of, let's say, algorithms or ways of using them in order to predict mortality. Because at the end of the day, what you want is, if I can predict that you're going to die, then I'm going to take the actions needed in order to prevent it. That's the idea. The idea is to prevent. So the sample that we show, it belongs to one of them. It's the short term. So it's a regression, logistic regression, and it's in the short term. So and then we improve, as Rafael said, then we improve the current best model in the 2012 of FissioNet. So that's something that it has its relevance and it has some meaning. Then the other 2 parts we didn't develop so far. So the idea is that we can do the same, but the approach is, you can use in the first. So my approach and the idea that we share is that we can have, for instance, IBM Watson. So IBM Watson can be in the long term, because it's very complex. You can include a lot of knowledge. And you can even learn about that knowledge and make inferences and reasoning, so on and so forth. And you can treat different types, of data, okay? So that is very complex. It takes time. Maybe it's not something that you can use in the intensive unit care, because the person is going to die before you to have some reasoning about it. But then you have that in there. IBM Watson, let's say, or whatever. So knowledge-based systems. In the midterm, maybe you don't have like a very complex systems as in there, but maybe you can have something that can learn throughout the time, okay? I don't know, we can say that we can think about, I don't know, it could be ensembles, could be anything like that, but something that can learn throughout the time, okay? And then the response time that you need is not so short. And in the short term, it has to be a model you have learned and is working right now, that's it, okay? You have rules pretty much, or a model that just tells you like, what you have to do. And in this case, what we do is just predicting if that person has a high probability of dying or not. Because in that way, you have limited resources in your hospital, then you have to take care, firstly, for those people that you think that has higher probability of living, because otherwise, you're going to get the worst of the options. So that's what we were trying to do there, to help to decide, given that you have limited resources in the intensive unit care, what is the best option? Who is the person that you have to save? Okay. So, but the approach is general, so we work only in the short term. We are waiting to work in the others because we have data and we have some. Also, we collaborate with hospitals, so we are trying to work in the other scenarios.
Very interesting.
Thank you very much.
Thank you.
Last minute question. Okay. Okay. Thank you very much.
Thank you. Thank you very much.